Okay. So the question is, if I did end minus start divided by 2, does that give me 3? Does it give me the right midpoint to start?
Yeah.
It does.
Yeah.
And if I were looking for numbers here and I cut off, let's say I did this, right? Mid is 3. So what if it were the number we're over here that I was searching for? What would I do? What do I get rid of? The right, from starting from where? Do I get rid of 4 and above?
No.
No, I get rid of 3 and above. Why?
Because you already know 3 is not.
I've already tested 3. I've said, hey, 3 is the midpoint. Is that the target? No, I can get rid of it. So I've gotten rid of all of this. What's my mid now? 1, which is 2 minus 0 divided by 2, right?
The right side won't work.
Correct. So you have to be a little bit like, so that's why you have to add the 2 together and subtract, right? Because it works if I'm going left, but if I go right and I cut this off, what's 7 minus 4 divided by 2? 1. And I'm looking for a target in this space when I know that I'm already limited over here. Okay, that's why we have to add my right and my left together and divide by 2, not subtract, right? So that's just a common misconception potentially. Okay, so we're gonna keep going through this thing. I gotta step back into binary. Oops, I just lost it. Damn it. I didn't step into it quick enough. Let's see where we are with our console. Yep. What are you trying to see, Alex, when we do it?
So it just goes to the end.
It's just going to keep doing recursive call. So it's just going to recursive call stack, just changing the midpoint each time. But yeah, I'll just step into everything.
Right. Until start.
Yeah. And so, all right, we get here. There's our first recursive call, right? S is 0. We got this. We get a midpoint of 3. We eliminate everything from 3 down. So we got another stack here. S is 4, end is 7. Our midpoint will be
5. Oh, 4.
this is so what's my midpoint on this one, everybody? It is 5. Why be confident? 5. 7 plus 4 divided by 2 is 5.
Yeah.
It is 5. Yes. So we get a midpoint of we go. Hasn't even calculated it yet. Midpoint of 5, right? What's going to happen now? I'm looking for 19.
17. Go mid plus.
Yeah, so my mid, right? It was 4. My midpoint was 5. That's kind of weird, but right, that's 5 is my midpoint on that part of the array, right? I'm going to cut off everything from midpoint down. What's my midpoint now? Well, what's in 6, right? So I'm going to come down. We're going to get another recursive call. I got 6 and 7. That's all I'm left with. Midpoint becomes 6. We go through that. It's not there. What happens next? So here's what you're asking. I'm left with this. My midpoint is 6.
Now, left.
It's still higher, right? So I get here. I call binary search on. Well, both end and start are 7, right? Midpoint is 7. Yep. Okay, good. Right. So we get that. Midpoint is 7. We can look down here. Okay. I go through, does not equal target. It is greater than. So I call binary search on. What do I call binary search on here?
Just the next mid.
Well, I'm calling binary search.
Call on the element before 18.
Yeah.
You're changing the left and right.
Yeah.
Left minus 1 though. Left becomes.
But I'm returning binary search on the array. S is what? 7, mid -1,
6,
6.
yes. So the thing just doesn't run.
Yeah, so what I've done is I've pushed it to its condition where end is now greater than its start.
Oh, and if n is greater than the start, then you return.
Then I say it's not in there, I return -1,
Right.
and I'm done. But I've got, what, 1, 2, 3, 4, 5 calls. 5 calls? I've got 5 calls, but how many times does it actually go through? And that's actually, this is part of the key in terms of where I put my count. Because how many times did we actually do the binary part of it? 4, but depending on where you put your count, like if you put your count at the start of this thing, what's going to happen? Why is it going to say 5? Going to count the last one when I know that it shouldn't be doing anything because end is less than, right? So I need to put this count somewhere around, or at least before or after where I do mid. I need to do this test first, and then I can put count in somewhere in here. I made it a static variable, and then I could just print out that static variable at the end. So I should have it give me 4 with worst case scenario. Okay, questions on binary search? Okay, cool. I'm gonna, yep.
How did you declare the static variable? It's not letting me declare static variable.
Make sure you declare static int, not int static.
Yeah, it's static int.
Where?
It says sorry,
Oh, because you can't declare it inside of the method. Right, you don't want to declare the method, you need to declare it as an instance variable for the whole class.
Oh,
Yeah, so even before your binary search. Could we increment this thing in binary search? For fun, for fun, let's try and do it. Could we increment this thing as a can we do that? Can we increment this thing inside of the binary search by passing it as a parameter?
you have to pass in 0.
Well, no, we could pass in. What could we pass in? We could just pass in the number. Yeah, we'd have to return it though. It would have to be the number that we returned from the binary search, which we could do. We could change this just to return the number of counts as opposed to the actual index that we're counting to. But that's not what we want to do. So I think the way this is structured is probably the best way to actually do it. Okay. Questions on that? Cool. So what I'm going to give us is 2 things. First of all the stuff gone. Oh, let's hide that panel. Hide video panel. Hide floating tools. I don't need any of these things, right? Okay. For Friday, everyone's eyes up here for a second. For Friday, I will not be here on Friday. Mr. Boone will be in class. And you're going to work on 2 things. One, you are going to work on coming up with test questions. Okay. So everyone's going to come up with a test question that you would, that everyone else in the class will take.
Oh,
So test question that you will give to everyone else in the class. It should be class appropriate. Everyone's going to come up with 2 questions. It should be not something that you're like, oh, I'm pretty sure that I'm the only person in this class can solve. Okay.
Its name.
So it should be, if it's not at all challenging, you will lose points.
What?
If it's not at all challenging, you will lose points. Okay. If it's too challenging, yeah, no, I want it to be stuff we covered in class and the appropriate sort of level for class. Yeah.
Does that include just the materials we covered from January, like the start of?
If you want to dip back into earlier stuff, you can do that.
Oh, no.
I saw a really, really good one the other day that came from an interview question that I haven't implemented. But you can use leak code type questions. But this one was just consider that you got a linked list. Right? I'll just do it very simply. Let's say we've got this linked list. And you've got linked to, and that is, I'll make this simple-ish. Okay, there's your two linked lists. Return a linked list that is the sum of those two numbers. So what's the sum of these two numbers?
15. Then 8.
Wait, how's that?
That's the linked list that you're returning.
Wait, why did it one?
Wait, what do we sum?
Carry the one. 15, carry the one.
Oh.
17, carry the one.
Like the
The literal sum of, assume that we have a number, 1,398 broke up into a linked list for each digit. 7,777 broken up into a linked list for each digit. Sum the digits. In a linked list. I like that.
Like, can we do it destructively, or like, or not really destructively, but like, can we lose the nodes as we go?
You return.
Like the upper nodes?
Yeah,
Sure.
don't like to the left, like just do like to dot next. I don't think just like losing,
Right.
I can ask.
Yeah. All you have to do is return that linked list at the bottom. So you can't lose the 9
But we don't have to come up with a constructor or anything like that, right?
for that, no.
Or like for the nodes.
No, you'd assume, so typically, if you got this as a question on leak code, you could assume that you would be given the structure code for your linked list.
And that one would be singly linked.
Yeah, singly linked. So I might give you that one. But does everyone understand the assignment there? And then you're gonna have a worksheet to work through. So there'll be some actual questions from a worksheet. You're also coming up with 2 questions of your own. Yeah, there you go.
Multiple choice, or like,
No, if it's multiple choice, it's gotta be pretty interesting multiple choice. And the multiple choices that I really like of late, because in my graduate class, like multiple choice, super easy, right? A multiple choice with 4 or 5 answers, where it is any possible combination of those answers. It's not like, oh, C is the right answer. It could be A, B, C, and D, it could be A and C, it
select
could
all
be.
that apply.
Select all that apply. They are the best multiple choice questions. In just such a wickedly awful way, because. It is, well, but it's really good for multiple choice questions if you want it to be slightly challenging. Either your question.
So was that like that question type of Harvard Finance?
Say, is it what? Sorry.
Like that's from Harvard Finance?
No, this was from a, LeetCode has this thing where, do I still have it up? LeetCode has this thing where they do, I get emails from them, and this was from some, I could try and find it if you want.
It's like the web time, like the fastest web time.
Of that, you should be able to do it in linear time. It should be O(n). No, theta, why would it be theta of n? We're gonna be really like, why would it be theta of n?
Oh, if the result is one more digit of them.
Well, what do I have to do? That's weird. Do I have to go through every number? Everyone think about that for a second. Why is that theta of n and not O of n? Huh? Do I have to touch every number in both lists? Yeah, I can't add up any of those. I can't like add those two without going through each of those linked lists. So it's theta because I have to touch every piece of it. Yes?
Oh, yeah.
Okay, as opposed to,
But Mr. Tom, what if
Yeah.
the result is like 5 digits instead of 4?
gotta add a new node.
That makes the runtime worse.
It would make, well, it makes it, what's the worst possible? What's the worst? Let's say I've got 10 nodes. What's the worst possible? How many nodes would I have to add ultimately? Well, but if I have, like, if this were 8, no, if this were 8, I'd have to add an extra node.
Yeah,
But how many possible nodes would I have to add?
it's like 99, well, 90. No, but it's.
No, think about this. If I maxed out all these numbers,
Yeah, 9999.
how many nodes would I have to add? I'm adding. Think about it. Stop. Everyone stop for a second. Here, we're gonna do, hang on.
Wait, this is.
We're gonna do,
5 digits.
stop for a second. I'm adding, yes?
Yeah.
How many nodes might I possibly have to add?
One.
And that.
What if there were 100 digits?
There can be 100 digits.
Sure, if I have 100 nodes,
What we do.
how many nodes would I possibly have to add?
Still.
Still one.
Yeah.
It's only one. Because the worst I could have would be 2 9s here.
Oh,
Yeah,
right.
yeah.
Regardless of how many other things there are, it's just one. I only have to add one node, so it's not actually adding that much to the time complexity. Okay, I'm trying to find this thing and I don't want a happy leak code shirt. But I know I got. Hi, leak coder. Leak code sent out a thing. They do.
How do they do? You just like give you a code.
Well, I mean, they don't give you leak codes in an interview. They give you those problems, like they will give you that problem. But it's almost always whiteboarded. So they do what we do on the whiteboards. They'll say, here, do this problem right here. And they'll give you the whiteboard and say, okay, first of all, what's your time complexity? What do you want to do? How are you going to solve it?
Like the time will be like 30 minutes, like, I mean, the total time for you.
Depends how good you are. I really wish I could find it. Leak code.
Someone.
What did I do with it? Now I'm frustrated because now you really want me to show, I want to show it to you. And I threw it out. Why did I throw it out? Hang on. Leak code, makes interview, crash course, no. And I don't know why, maybe I erased it from my email too. Let's look, trash. Except that should be giving me my trash email too, right? Sorry, I'm not going to show you all my email. So we're not going to do that. But let's see, maybe I can look it up a different way. Yeah, no. Code. Whatever. But essentially it was a they had a I don't know if they must have somewhere in LeetCode, they must have some sort of a why am I not logged in? They must have some sort of a blog in LeetCode. Online interview. Oh, here you go. Why am I getting into an online interview? Yeeks. Okay.
Well, I might need like one of those ChatGPT glasses.
Yeah, you can see they do all that. You can see they do all this stuff in here. Discuss.
What's DeepSeek?
Oh God, what's DeepSeek? DeepSeek tanked our economy by $1 trillion 2 days ago.
I like NVIDIA.
Yeah. So DeepSeek's it's a Chinese AI model, and what's that?
The budget was 5 million.
Well, there's some big question marks about what their actual building budget was as opposed to their testing budget. But ostensibly what they're saying is that they can run a system that's better than OpenAI's with like a quarter of the chips. So they don't, essentially what they're saying is that NVIDIA, we don't need NVIDIA anymore because everyone can run all their AIs on a quarter of the chip. So if you look at, you ready? Let's go look. You guys are totally sidetracking me, but if we look at NVIDIA, let's go look at,
It's like the price of an AI, like we're building, it's like went from 100 million to like 2 billion.
oh, why is it NVIDIA futures? Oh, so it starts. So NVIDIA stock, yeah, they're rebounding a little bit. And quite honestly, when you look at this, it's sort of stupid that everyone got all their everything in a twist because, oops, you can't see my screen. So NVIDIA stock did that on whatever day, what's today, Wednesday, on Monday. So they lost, it was the biggest market loss for any company in history. Market capitalization loss. So they lost, I think, they lost some outrageous $600 billion in value.
Just because of DeepSeek?
Because of DeepSeek, yeah. Because essentially the issue is that if it's possible to run AI on that few chips, then that's what everyone's now going to push towards. And so we're just not going to need as many chips as people thought we were going to need. But now you look at this now, this is coming from a lot of experience in the investment market, right? That's a huge drop. It was like 13% drop. And here's where we are today. That puts us where we had never been ostensibly back in October.
Oh,
Right? And if you look at the long term, look at the stock long term, it's stupid. So days, months, range. All right, let's just do this. My fingers aren't dexterous enough to do this. Month. There, that's NVIDIA stock. Okay, so if you look at
wait, what's this thing below? What's the graph below?
don't worry about it. Historical volatility. It's based off of options. There, we'll go a 1 week chart. There you go. So NVIDIA stock was trading at $40 going into January. So it's still at 100. It's still twice. It's 3 times the amount it was a year ago. So a 13% drop is literally nothing.
Okay.
So yeah, if your grandmother owns NVIDIA, don't worry. Okay. How did you guys sidetrack me so badly? Okay. So other questions on your questions for Friday? Cool. All right. I'm going to give you some sample questions. Here, this is going through some exercises from our disjoint sets. I'm not going to give you these two. Maybe we'll look at one of these, but we have the following. What's a WQU? Weighted quick union with path compression. What is the height of the tree after we call is connected 8, 9?
1.
We got to vote for 1. We got to vote for 2 or second vote for 1?
1.
Oh, wait, 8, 9.
1, 1.
Wait.
I'll wait.
Yeah, yes. Yeah, 1. Yeah, 1.
Anyone want to go with anything other than 1?
15.
15, yes. Okay. Why is it 1?
9, 7, and 8.
Yeah, we touch everything that's in level 2 and 3, right?
Yeah.
And each time we touch anything that's not in that level, we go through. Let's go look. Should we look at problem 2? Let's go look at problem 2. Are you guys having flashbacks? Okay, problem 2. Suppose we use a BST. No, we don't want it. Really? Problem 2? That doesn't see. Oh, problem 2. Weighted quick. Yeah. Whew, all right. We are about to do binary search trees. So draw a valid weighted quick union tree with the worst case height given sizes of n 1, 2, 4, 6, 8 in the boxes below, where n is the number of items in the weighted quick union. First 2 are done for you. Recall that the height of the tree is the length of the longest path from the root to any leaf.
It's like, have it like,
You tell me, do you?
yeah.
So we're going to end up with ostensibly 0, 1, 2, 3, 4. What do we go up to? 5, 6, 7, 8.
No, you
Yeah.
just chain like sets of two.
Oh, yeah.
Well, you keep going,
Yeah.
right?
Yeah.
Like, yeah, because it's log base two is the runtime, so you just, it's like that.
Do we understand what Gordon's saying?
You're like, you do like 0.
Let's make sure we understand this, because maybe we'll see this on the page. Do we understand this or not? Do we have questions about this? Sure, come on up, draw it up. Gordon, you want to draw what you're thinking there?
Yeah,
Why don't you just draw it to the right-hand side of the board?
well, it's
It's
like,
not right on
And
the,
then 0, 1.
you could start with this and then just do what this box would look like. But do it right next door, yeah, thank you.
yeah, it's like,
Does that one work? Sort
yeah,
of.
it's like 0 to 1, and we have like, 2 to 3.
Yeah,
And then we have like
we'd have a whole new set of that, right, doing the same thing.
4, 5.
Wait, oh, you put three, you got 3 in there twice.
Oh,
Let's give you a marker that works. Try to-
5.
But is that what you want there?
I mean. Yeah.
Really?
I thought here, everything else.
Say again?
Like. The decompressing.
Oh, no, actually, it's like here, right?
What?
And then like that, right?
Yes or no? On the second one.
Heck is. Yeah.
This is not path compression.
Oh.
Weighted quick union.
Oh.
Is that correct?
But 2 has a bigger set, you're connecting to the smaller, don't you connect to?
Well, you go from 2 to 4 to 6 to 8. It is ostensibly a recursive structure, right? What do we know? This structure is what with this structure?
What's?
It's the exact same.
Yeah.
And I just connect these. This structure should be the exact same as this structure.
Yeah.
So if I did 16, what would it look like?
That times.
That
2.
attached over here. Right?
Yeah.
And we can go back and look at, I'd have to go find it now. Not there. You remember we went through and did the worst case scenario when we were adding things, right? Because you have to add them we're adding them one at a time. We're not taking existing trees and slamming them in there, right? So it's just a recursive structure. We get this attaches to that. This structure looks exactly like this, but connects one down.
Right.
Right, and the same thing with if we kept going. Okay, next question. So let's look at, which problem was that? Problem 1. Solutions, let's see, should we look at the solutions? And then problem 3, of course, resulting tree will have height 1. Every node along the path from 0 to 9 will now have parent 0, right? That was our path compression from that one. Let's go look at our solutions. There you go. See how do we do?
Yeah. Yeah.
But if 4's connected to 0.
Right, so what 0, 1, 2, 3. Yep. 4, 5 come off of 3. If we think about structures, right, we got this 3, so actually, wait a minute.
Oh, wait, 4 is connected to 0.
3 connects to, yeah, so when we connect 3. That's a little weird.
That only happens to be compressed.
Yeah, so, well, no. If we look at this though, this is like, look here.
Yeah.
Right, so we've got that structure and then that structure. Your 4 just needs to connect to 0.
Oh, yeah.
This structure and this structure are exactly the same, which is what you have. It's just that your 4 connects to 0, not to 2.
And the height is log n, right?
The height is log n.
No, but we're drawing like the worst case scenario, right? So shouldn't 4 be connected to 2?
Well, no, because remember when we do, even when we do weighted quick union.
Oh, right.
Yeah.
Oh, wait, oh.
Okay, let's do conceptual. I don't know that I'm really ever going to give you one of these questions. Which of the following arrays could represent a valid weighted quick union structure? These are kind of ugly. And first of all, what does it mean that it's a valid weighted quick union structure? Well, but we're not even looking at height. You got to think about where these like,
Next.
right? So what is this? What does this one mean, first of all?
Those are the pairs.
Yeah, good question. Where's the root, right? So with this one, how about, well, this one? What's the root here?
Index and then what's
Index 1,
1.
right? If we think about that, and what's connected to 1? 4,
6 and 7.
6 and 7, but this is saying 8.
That's not correct.
So this is, well, this is connected, this is 4, this is connected to here, right?
No.
This is connected to here, so now we're up to 1, 2, 3, 4, 5. This is connected to 8, so I mean, like,
Yeah.
right? It gets a little messy there. Do we think that this one's valid though, if we look through it?
Yes.
Okay. Oops, it's not gonna let me checkbox it.
Wait, that one's not valid, right? It's not 8 items.
Here?
Yeah.
Do we really want to go through the whole thing?
0, 1, 2, 3,
All right.
4,
I'm gonna 0, 1, 2, 3.
9.
I think that one's right.
The last one is off by 1. It should be -11.
It should be -11. Is everything connected?
Yeah,
It's still like a dude.
No, but there's only 10 numbers in there,
yeah, but you start off with -1 for a thing, correct?
but it's its own root.
No, the last, yeah, that last one's correct.
I think this one's correct too. I'm gonna vote for 2 and 4 without doing any more particularly. Oh, no, invalid. There's a cycle, 2, 4, 8 to 2 to 4 to 0 to 8. Let's look at that and see on the first one. Oh, we didn't go with the first one anyway. Okay, second one, invalid. Maximum height 4 is greater than log 10. So we weren't paying attention. You'd have to actually draw these out. Invalid, size of the tree rooted at 9. And that last one is the only valid one. Because again, it's -1 because it's its own root. So it counts as having one thing in there. Right? Because when you start, everything has its one thing in there. Okay, I don't think I'll give you one of those. Define a fully connected weighted quick union is one where all the elements are in the same set. What is the maximum and minimum height of a fully connected weighted quick union with 6 elements?
And the one was 1, yeah.
Okay, minimum 1,
All base 2.
which would be what?
Oh, so.
6? Okay, we got 1 and 6. Anyone want to propose any other answers?
Wait for the maximum.
Well, I'm just hearing numbers. So far I've heard for a minimum 1
Wait,
and a maximum I heard 6.
what happens to the decimal?
Anyone want to go with other numbers?
Max output. Minimum.
Max of 3?
Minimum 0.
Minimum of 0? Okay.
What? Wait, 0. No, isn't it like?
Wait, isn't the maximum
top?
2?
The very top number is 0. If you just have a root, it's 0.
Yeah. So everything. You only have a root in.
Isn't it the maximum 2?
So if you have.
Maximum of 2. 4 of maximum? All right, so far, for a maximum, I have 2, 3, 4, and 6.
No, I get it.
All right, what'd you have originally? Did you have the 6 originally? You had 3 originally? 5.
Like, how you guys?
Are we just like throwing out every integer between 0 and the 6 that's there? 0.5? You can't have a 0.5 level. Okay, so let's read this carefully. Fully connected weighted quick union. Okay, what is the maximum and minimum height of a fully connected weighted quick union with 6 elements?
Which of everything's connected?
Yes.
5.
Wait,
I've got several votes for 5.
no,
6.
We're back to 6. We got.
no.
Does anyone? Okay, everyone's got to give me an actual vote. Sienna, are you going for 3 or what'd you say? 4. Okay, Mary. 2. Okay. We got 1, 2. You're 3? No, you're 4. You're a 2? You're a 2. Tony's with a 6?
Yeah.
Okay, that's 1 vote for 6. We got another 2. Donald?
5.
You're the first 5. Okay.
5.
We got 2 5s. Gordon, you get to do the deciding vote. We got 2 2s and 2 5s and a couple of 4s.
I'm pretty sure it's 2 or 3. No, it's 2, right? It's 2 or 3.
2 or 3. Okay.
I don't know what to do with like the decimal in the log. Oh, no, it's 2.
Minimum height is always 1. Maximum height is 2. Log base 2 of 6. Okay. Why is it not 5 or anything above 2? Because it's not compressed. We don't have path compression. It's weighted. We can't have the worst case scenario of a regular quick union. This is a weighted quick union. Okay, minimum height is always 1 because they're all just connected to the root. Okay. Whew. All right. How about this one? Suppose we have that's a good question. I like that one. Intent. Suppose we have a weighted quick union of height h. What is the minimum number of elements that must be in the weighted quick union?
Oh, wait, you
Like
just do,
H to the
H
power of
equals
2.
log to,
Oh,
H
right.
squared. No.
2.
H squared. So if I have, think about it, if I've
2
got
to the H.
6 things,
Oh, right. 2 to the 8.
2 to the H.
2 to the h,
Wait, hold
I
on.
know, H to the 2.
h to the 2,
Wait, is it? No.
h to the 2. Well, think about it, this has 6 elements in it. H to the 2 would be 36. That would be really deep levels for 6 things. H to the 2,
Oh,
2 to the
2 to the h.
Yeah.
What are we going for here?
2 to the H, 2 to the H, 2 to the H, 2 to the H.
When you solve the
Definitely
log,
two.
you get 2 to the H, right?
Yeah, because
Yeah,
H
log.
equals log 2 n. N equals 2 to H.
What's minimum, right?
Log
So it's
is 2
asking,
H.
what's the minimum number of elements? What's 2 to the 6th?
64.
So suppose we have this thing. Oh, so actually, what was the height of that thing? 2. So it's 2 to the 2. Is that what we're going for? Okay.
Wait, 2 to the 6 is 64.
Yeah, but we're not taking, it's not 2 to the 6, it's 2 to the height,
Yeah.
not not n.
Yeah,
Right, you said h. Okay.
yeah, see?
N will be greater than or equal to 2 to the h. Okay. Woo-hoo. Oh, look at the time. You guys have an awesome rest of your day. So I will give you some prep work for Friday, but again, I won't be here. Mr. Boone will be here, and you'll work on those worksheets. Totally lost track of time. You guys sidetracked me. Have a great day. If you were late, please erase my boards. Yep, have a good rest of the day. Sorry, I did not mean to keep people late. I guess I only kept you late by 30 seconds. No, you did, don't do those boards. No, I can take care of this one too. But just don't walk away with my eraser though. You got 6 erasers back there. Have a great rest of your day. Okay.
Thank you.
All right. Have a good day. Oops, I'm still recording. Oh, or am I still recording? How do I? Oh, there we go. How do I get back to my Zoom meeting and help me out? How do I get that? Well, I'm recording. I'm in a Zoom meeting. How do I open it back up? So stop recording.